So today, we're diving into Midnight, a new blockchain that's all about data protection. But what's really revolutionary here isn't just what it does, it's how it's being built. We're going to explore how years of hardcore academic research, not just frantic coding, are paving a totally new path for creating technology that's actually designed to last.
So let's kick things off with a pretty fundamental question, right? How do you build technology that actually lasts? I don't mean for the next quarter, I mean for decades. In a world like blockchain, where projects can literally rise and fall in a matter of months, this is the ultimate challenge.
And for the folks behind Midnight, the answer starts right here. Years, and I mean years, before anyone wrote a single line of code, researchers at Input-Output Research, or IOR, were battling these core problems on a blackboard. This isn't a story that starts with the product launch. It starts with academic rigor.
Okay, so let's follow the breadcrumbs. We're going to trace how these abstract mathematical ideas were slowly and carefully translated into a real, live, working network, one peer-reviewed paper at a time.
You know, this commitment to a research-first approach is really what sets Midnight apart. Think about it. So many projects just build fast, launch, and then try to patch all the problems later. Here, the entire foundation is a library of published, peer-reviewed scientific papers. Every single piece is mathematically proven and torn apart by experts before it gets turned into code. It's definitely the slower, harder path, but it's how you build something that's meant to endure.
All right, so let's get into the first major mountain these researchers had to climb: scalability. This is a classic stubborn problem that has plagued the blockchain world forever. Here's the core issue. As a blockchain gets more popular and handles more traffic, the main chain gets totally bogged down. It becomes slow. It becomes expensive. It's basically like a highway getting stuck in rush hour. So the question becomes, how do you add more lanes without grinding the entire system to a halt? The solution they came up with is brilliant. It's called partner chains. The idea is so elegant. Think of Midnight as a brand new, specialized chain that connects to a big, mature, secure network like Cardano. It uses what the research paper perfectly calls an umbilical cord, this cross-chain bridge, to borrow all of that security. This is absolutely huge. It means Midnight can be super bold and experiment with wild, cutting-edge stuff like privacy without having to spend a decade building its own massive security from scratch. Okay, next up is a really thorny problem that gets right to the heart of what Midnight is all about: making private transactions actually work when things get busy. The technical term for this problem is concurrency. Just imagine a private auction happening on a smart contract. If a bunch of people all try to place a secret bid at the exact same moment, their confidential transactions can basically just crash into each other. It creates a digital logjam where nothing gets through. This was a massive roadblock for any kind of serious private application. The solution came from a research paper called Kachina. Instead of all these transactions clashing and causing that logjam, Kachina introduced a totally new architecture. It allows multiple private transactions to get processed at the same time, in parallel, without interfering with one another. It's this breakthrough that keeps the network flowing and makes complex private business apps actually possible.
But the vision for privacy here is so much more subtle than just hiding data behind a wall. One of the lead researchers put it perfectly. It's about rational privacy. Think of it like a poker game, right? Sometimes strategically revealing a tiny piece of information can get you a much better result. In this model, privacy stops being just a shield and starts being a powerful strategic tool.
And, this research-first approach didn't stop with the technical problems. It led to a completely new economic design. And this one tackles a huge source of frustration for anyone who's ever used a blockchain: those wild, unpredictable transaction fees.
So, let's just compare the old way with Midnight's new approach. Traditionally, you have one token for everything, securing the network and paying fees. The problem? If that token's price suddenly skyrockets, so does the basic cost of just using the network. Midnight's model is different. It separates those two jobs. And the result is what everybody wants: stable, predictable fees. For any business trying to build on this platform, that's an absolute game changer.
So how does this actually work? It all comes down to two different tokens. First, you have Night. That's your main utility token. You use it to help secure the network through staking and for voting on where the network goes in the future. And then you have Dust. Now, Dust is a resource token. You can't trade it on an exchange. Dust is what you actually spend to pay for your transactions. And there's the really slick part. You automatically generate Dust just by holding Night. This creates this perfect, predictable loop for users to cover their costs without being held hostage by market swings.
But the research that went into Midnight isn't just about solving the problems we have today, it's also about preparing for the threats of tomorrow.
And that includes one of the biggest, scariest threats looming over the entire field of cryptography.
This threat has a really chilling name: harvest now, decrypt later. What it means is that right now, adversaries are recording and storing huge amounts of our encrypted data. They can't break it today, but they're betting that in 10, maybe 20 years, a quantum computer will finally exist that can just shatter our current encryption, exposing all of those old, sensitive secrets.
So what's the shield against this? It's a new class of encryption called lattice-based cryptography. Try to imagine a lock that's based on a mathematical problem so mind-bendingly complex that even a powerful futuristic quantum computer wouldn't be able to find the key. That is the kind of future-proofing we are talking about.
But this is so much more than just building a better defense. This advanced cryptography unlocks something that many have called the holy grail of data science: fully homomorphic encryption, or FHE. I know it's a mouthful, but the idea will blow your mind. It lets you perform calculations on data while it is still completely encrypted. Imagine you could add two secret numbers together and get the right answer without ever actually seeing what the numbers are. Think about that for a second. Two hospitals could combine their sensitive patient data for research, get a result, and neither one would ever have to reveal a single piece of private patient information. This is what makes a truly privacy-first digital world possible.
And that really brings our whole journey full circle, doesn't it? This quote just captures the magic of it all. These incredibly abstract mathematical theories that most experts thought were decades away from being useful are now literally the engine rooms powering a live network.
Ultimately, the story of Midnight is a powerful testament to taking an evidence-based approach. It proves that the most lasting, the most revolutionary technologies aren't just coded into existence overnight. They are painstakingly derived from a solid foundation of mathematical truth and the slow, deliberate process of real science.
Which leaves us with a pretty fascinating question to think about. In a world full of disposable apps and fragile digital systems, what becomes possible when we finally decide to build our digital world on a foundation of provable mathematical truth? Thanks for joining